The Battery Buzz podcast is brought to you by H.B. Fuller Company. H.B. Fuller is one of the battery industry's leading suppliers of adhesive, encapsulant, coatings, and sealants for the EV and battery industry.
Hello and welcome to Battery Buzz, the show for battery professionals by battery professionals, keeping you connected to what's new with batteries and the people who help build them. Your battery specialist hosts today, Elizabeth Canaz and me, Jermaine Maria Salvaraj, are back for our next episode, so let's get started. Today, well, thank everyone for joining us. Today's kind of a special episode for us. We haven't really done one of these. But it's super exciting. Today is kind of what we call a product spotlight on one of our new technologies for the battery space, our EV Therm 602. So this is going to be exciting, right, Elizabeth?
Yeah, we're excited to share some of the key attributes of the EV Therm 602 and see, let you get to know more information on this new exciting product. And it's a dielectric coating for cold plates. And it's what I think is really unique about it is that it's thermally conductive as well as highly dielectric. So it has good dielectric strength and volume resistivity. So I think those are some of the key factors that really make this product unique.
Yeah, because traditionally, right, it's sometimes you have to choose between those two properties, right? Either you have something that has good thermal transfer for like between your cells and your aluminum base plate, or you lose that and have super high electric resistivity. But this is kind of a hybrid product where you get like the best of both worlds, which is pretty, would you say it's kind of unique for the industry?
Yeah, I would say definitely. And I think that, having a 1 watt per meter Kelvin in the dielectric coating itself can help boost any other cell to cold plate, thermal heat transfer efficiencies just because the coating is so thin. It's 120 microns, plus or minus 30. So you're really getting a really nice thin layer of material. And that really is really key when it comes to having efficient heat transfer because you don't want thick coatings or thick materials because that actually impedes the heat transfer and makes it less efficient.
Yeah, and I mean, well, and then also you're putting down more material, right? If you have a thicker coating, like because we've seen maybe double or triple in the industry. And yeah, just a thicker coating, right? What does that mean? Like you're putting down more material, you're potentially losing more material in like the overspray that you would have. And also like curing time, depending on what kind of technology you're using. Thicker materials usually take a longer process or a cycle time. So this is kind of cool because it's a thin coating that you can spray relatively quickly and then off you go.
Yeah, and that's a great point because a lot of the other materials, they have to go through the oven and cure. So you have a larger carbon footprint. So you might have to go through the oven a couple times. But the one thing we didn't mention is it's a UV cure. So it's instant.
Whoa, I can't believe we forgot.
I know, mind blown. So we probably should have mentioned that early on. It's a UV cure. So it's only one light, one cure, cures within seconds, and it's 100% reworkable.
Yeah, and reworkable in the sense, right? So say like taking a traditional powder coat, if you were to have, say, like a pinhole or whatnot, you would only catch it kind of after that post bake, right? And then you can't really go and rework that, is kind of some of that feedback that we got in the industry. Whereas this, kind of what you're saying, right, with UV curable, it's kind of going through like a conveyor belt, right? And the lights are hitting it. But until it goes through that UV oven, right, the material is a liquid. So say you spray it and you see a pinhole or something, or someone touched it and now there's like a gap where arcing could happen. You could just quickly go over that spot before you send it through the initial oven, or even after. If you see something, you could just spray it on top of it and it will kind of stick together, which is neat.
Yeah, and I think that's a huge value add for customers, just because, cold plates are expensive. Coating them is costly and time consuming and labor intensive. So the end customer will really see a benefit in cycle times, and equipment costs, so ovens, the cost of ovens and the time. And also, I know that the ovens, sometimes warp those aluminum plates, so then they have
Yeah.
deformation because of the high heat of the oven. So really, I think it's they're gonna not lose so much money, because I know some customers were like, we're really like our scrap rate's really high, and there's nothing they can do to use these once they're powder coated. So I think this is a really great solution to overcome those issues.
Yeah, totally. Yeah, I think getting rid of the bake aspect of it just saves so much time. And even if, you're an end user or a battery manufacturer, a lot of those customers don't do that process in-house, right? And
Yeah.
so this kind of gives them multiple avenues to take. Either you can now bring it in-house and do it yourself because the process is so much easier and less, like you said, energy intensive, where it might make sense for the business. Or if you don't even want to deal with it, it's easy for integrators or for other spray coating labs or businesses to kind of take that on and incorporate it, and do it for you.
Yeah, I think, and that's really, it kind of opens up some flexibility there for our customers, and reduce costs maybe even further by taking it in-house if that's something that they're interested in doing.
Yeah, absolutely.
And the other thing that I think is really interesting about this product is that you're able to, even if you like tape, some customers use capped on tape, and that's pretty labor intensive as well. So it removes like the labor portion and the carbon footprint in that, but also we found to even further get benefits to our customers is that we're able to clean with like flame, corona, plasma, and remove solvent altogether. In
Yeah.
some instances, we've seen a solvent station could cost a customer up to $1 million additional cost for equipment. So I think that being able to just use a simple cleaning method that doesn't consume any solvents, you don't have the EPA requirements and all that. So I think that's another cool thing about this product.
Yeah. Wow. That is crazy. And I mean, eliminating solvents, I think, is just as a business, right? Especially when you're dealing with battery manufacturers, right? Like
Yeah.
flammable liquids are kind
Probably
of,
not really,
yeah. There's already so much going on the cell level. It's like the last thing that they want to worry about. And yeah, I mean, using this material it's so easy to do, right? So technically, right, it's a two-part but the part B is pre-weighed out, and you would just mix all of it into the part A and then just kind of mix it up, which is super hands off, right? You just put it on like a drum roller or a pail roller, let it do its thing for, an allotted period of time, and then you're ready to go.
Yeah, and so and that's the other thing. It's a simple meter mix piece of equipment. It's not anything that's specialized. It's off the shelf, and you're able to coat. And also the other thing that's unique about it, it has the UV indicator. So if you're not sure if you coated something, you can just shine a light on it. You can see, oh, I missed this part of the plate or something. So that's one thing that our formulation chemist included in there to help with that.
Yeah. Well, just coming back to like the defect rate of stuff, right? Like if customers, like you were saying, we had people who were saying, I mean, I think maybe 10% is somewhat of a normal defect rate for cold plate coatings.
Mhm.
But if there's parts are super complex, or like you said, they're super thin, we were getting told like upwards of like 30%, which is
Yeah.
just an insane waste of money. Especially if they're coming from overseas and whatnot, right? Paying all the transportation costs with everything going on. There's so many variables, and it's it's a lot to manage. So I think like anything that you can help with almost coming down to a single percentage defect rate or even zero. Um, this product takes care of a lot of those. It ticks a lot of those boxes, which I think for a manufacturing process is super important, right? I think that's the big thing, is that providing a product that can help OEMs kind of get their battery designs off of like the conceptual stage and actually mass produce it is key for the industry.
Yeah, and I think something that performs well too, because the dielectric strength is 70 kilovolts per millimeter, which is really great. And then the volume resistivity, is, 10 to the 13th. So I think that that's just really critical for electrical isolation and current leakage, which, as we all know, at the end, we usually test for high pot and then dielectric strength, with Jermaine's you're a resident expert there.
I wouldn't say that, but yeah, it's a super important test, right? And it's almost a standard. It's an inline test that almost everyone is doing. So if you being able to have the coating kind of go through the process, you can take it to a table, hypot test it, you're good to go. Then you can build your battery on top of that and know that once you hypot test it down the line, you're not gonna have it fail. Because right, even after you build everything, just one little defect on your plate will cause that whole module or the whole pack, even depending on your design, to be scrapped, which is a huge waste of money. So being able to spray it, test it right then and there, I think is critical. And like you said, yeah, the electrical properties are super important.
So do you do both, like the brush test and the matte test, or what's kind of the preferred method there?
I feel like I've seen both, right?
Mhm.
So I feel like if you're just doing it on a plate, the brush is super easy and it allows you to kind of check even like near the corners just to make sure you're kind of check geometry, right? Brushes. But sometimes it's not just a plate. It's an intricate design. Sometimes it's a box, because you want to get all the sidewalls coated. So there, I feel like the brush works great.
Okay.
But I've seen the matte as well, like a silicone matte.
Mhm.
And that way, that's nice too, because it's like if you have a really huge part, you just have a mat that covers that entire area and it'll test the entire thing. So
Yeah, and those are really important too. So I think even those testing equipment it's relatively like easy to acquire and use. It's
oh
not
yeah.
anything
I would say
complicated.
if I could figure it out.
No.
No,
You should
that's what
say it's
I'm
highly
saying.
complicated and few
Yeah.
people know how to work this
Yeah.
equipment.
Yeah. No, I think oh, and it's the product, this is super random. We were just talking about testing. It's flame retardant.
So it's UL94 V-0 rated.
Yeah. Yep.
And that's important. I mean, obviously you want most of the components within your battery pack to, not catch on fire if there's a thermal runaway event.
Yeah. And even just from our side, right, as a material supplier, and I'm sure you see this right when you're talking with people, with customers, it's like a directive where every single material has to be this rating for it to kind of even go in, regardless of what the application of that product is or what it'll actually see. We have those conversations every day. But it was cool from our chemist David to kind of take that on and realize like nowadays, like the industry is kind of going towards, okay, every material has to be V0. And so this product meets that as well. Because I know some of the other materials are not that way.
Yeah. And so I think it really I think Dave did a good job in capturing all of these critical components that this coating needed to do in performance. That's not really easy to put all into one product. And so I think he did a good job, with the challenges that we set out for this material for, the battery market.
Yeah, absolutely. It's exciting. So Elizabeth, tell me about kind of availability or like where people can hear more about it. About like using it, applying it, kind of stuff like that.
Yeah, people can reach out to our team, myself or you, Jermaine, and we can point them in the right direction. We have a manual that's step by step on how to use it. We have experts that, with the equipment we've got equipment in our lab. We have a contract manufacturer that's spraying this so we can help coat these parts. And we've done over probably 1,000 cold plate designs. Some are flat plates.
Yeah.
Some have very intricate designs, but we do prefer chamfered edges. So for anybody out there, if you're designing a cold plate, no 90-degree angles, chamfered edges are preferred, please. But I think, just reach out to myself or yourself, Jermaine, and we can get you guys started on this journey of, low scrap rate, electrical isolating material.
Absolutely. And we are starting to kind of see this this application, right? So it was designed for cold plate, obviously, but we are kind of turning this into a family of products. Like that's kind of the next generation is the electrical protection cone in the coating space, in the coating world, as far as lightweightness, ease of use. So that's exciting too, right? This product kind of kickstarted, I think, more development and more innovation, which is exciting.
Yeah, definitely. And we're looking at, coating cell cans like prismatic cells, bus bars. So there's other applications where we see that this product could potentially benefit the battery space.
Yeah.
And even like energy storage. So pretty broad spectrum that we're looking at here.
Yeah. I'm looking forward to it.
Well, I think this concludes our first ever product highlight spotlight. And we want to thank everybody for joining us. And hopefully you found this interesting and exciting because I know we're excited about it. So since this is all the time we have, thank you for joining us. And we'll have another episode next month of our Battery Buzz podcast. And we'll be talking to another very special guest that we'll announce shortly. And if you would like to leave comments or questions or give us your thoughts, please subscribe, like, follow, and check out our electric battery adhesives page on LinkedIn.
Thank you, everyone.
Bye.